You will use arrays in JavaScript a lot because they're one of only two built-in data structures that you have. You have the array and you have the object. Arrays are indexed collections. You can store anything in the array, so the various elements don't have to have the same type. If we look at the example given here, you can see I've created an array. The square brackets are the array literal syntax, and within the array we have a string, a one character string, the number 1, a regular expression, and an empty object literal. When I say that arrays are an indexed collection, it means that we can use this square bracket notation to access array elements by their position in the array, beginning at 0 for the first element. Arrays also have a length property which tells you how many items are currently in the array. As I mentioned, the array literal syntax is the square brackets with the items in between. And there's quite a lot of very handy methods on the array object that we will take a look at in this example. First thing I'm doing here is declaring an empty array and then outputting the length property of an empty array. Obviously, we expect the length is going to be 0. Next I have an array of letters, A, B, C, and D, and I'm looping through the array, starting at 0 up until whatever's one less than the length of the array, which will be the highest index, and just outputting the value that's found there. So we see A, B, C, D as expected. If I continue working with my letters array that currently contains A, B, C, D, I can use the array's push method to add another item onto the end of the array. So there's push and pop methods that we can use to make an array behave like a stack. So if I output that, we can see that E has now been added onto the end of the array. If I output letters.pop, that's going to pop the last element that I just put on the end of the array. It's going to pop it back off, which was E. So you see we get E back, and now if I check the contents of the letters array, it's back to the starting point because E's been popped off. Arrays have a reverse method that reverses the order of the items. So again, I continue using my ABCD array, but now when I call reverse, the contents are now DCBA. Arrays have a slice method that works very much the same as the string slice method. So the two parameters are the index of the first character to take, and the second parameter is 1 greater than the last character to take. So if we slice the array 1, 3, it's going to take B, and it's going to take C, which we see here. The splice method is most commonly used to remove part of an array. The arguments are a little bit different to slice in that the splice method, the first argument is still the starting index to take, but now the second argument is a count of the number of characters to remove. So in my example here, I want to start removing from the character with the index 1, and I want to take 2 characters. So the character with the index 1, I'm going to start with B and take 2 characters, so that will be B and C. So those 2 characters will be removed from the original array collection and returned. So if I run that, we get the 2 characters that have been removed, and the remaining characters in the array A and D. JavaScript arrays have a sort method which we can use to alphabetically sort the items in an array. I've got here an array with a whole heap of different characters, and I'm just calling the sort method. And the result is the elements of the array sorted alphabetically. If I try again, and this time I want to sort an array of numbers, when I call the sort method, what we get is not what I had in mind. The numbers are also sorted alphabetically, so they're not in numerical order. You can see it says 1, then 10, then 2. Luckily we can fix this. The sort method takes an optional parameter, which is a function that can be used to sort the items. The function must return 0 if the items are equal, a negative number if the items are currently in the correct sequence, and a positive number if the items being compared need to be swapped. So for sorting an array of numbers, I can implement this comparison function simply by returning the first value minus the second value. And now if I sort using that comparison function, this time the array items are in correct numerical order. I promised there would be additional libraries to help you get more done with JavaScript, and here's one, Underscore. Underscore is an open source library that brings functional programming support to JavaScript. It adds a lot of functions to arrays and also some functions for working with other functions and for working with objects. Underscore can be used in an object-oriented style or in a functional style, and the decision is really one of personal preference. If we have a look at the example I have here in this page, it's a basic demonstration to show the differences in the style. To begin with, I declare an array containing the numbers 1, 2, and 3. Then I'm using the underscore library and the each function. First, let's try the functional style. Here we have the underscore object. I'm calling the each method on that object. The first parameter is an array that I want to enumerate over. And the second parameter is a function with one argument. And that function will be called once for each item in the array. That's the functional style. Now the object-oriented style works a little bit differently. We use the underscore function to wrap the array that we want to work with, and then we call the each function on that wrapped array. And this time the function has just a single parameter, and again it is a function with one argument that gets called once for each item in the array. So these two examples, the functional style and the object-oriented style, are exactly equivalent. Before we go on to the examples, let's quickly take a look at the underscore documentation. It's just a single page, but it is quite thorough documentation of all the methods. There's a source download of underscore and a minified and compressed download of underscore. There's a discussion of the object-oriented and functional styles that I've mentioned previously, and then there is a list of all of the functions included in underscore, and if we select any of them, there is some brief documentation and examples. On to the example. The first examples I have here are the ones that we've already seen in the PowerPoint. I'm using the each function, firstly in the functional style and then in the object-oriented style. The each function provides an iterator for collections so that we don't always have to use the for statement, the for loop. This first example is the functional style, looping over an array containing the numbers 1, 2 and 3 and just writing the output. So we see the output 1, 2, 3. Then again, doing the same thing, but this time in the object-oriented style. So first thing I do is use the underscore function to wrap the numbers array, call the each function, and for each item in the array, write the output. Again, we get 1, 2, 3. The map function is starting to get a little bit more interesting. I'm going to work with the same numbers array containing 1, 2, 3 again. Map translates one collection into another collection. So we provide a function, and that function is called for each item in the original array and returns the value to be placed into the new array. So in this case, I'm using the map function to double each value in my array by multiplying it by 2. If we output that, we see 1, 2, 3 doubled is 2, 4, 6. The next function I want to look at is reduce. Reduce takes a collection and distills it down to a single value. Here I'm using reduce to calculate the sum of all items in my doubled array. If we have a look at the output of that, 2 plus 4 plus 6 reduces to 12. The select function is used to filter a collection. Each item in the original collection is passed to the function we give to select. If that function returns true, then that item is included in the new array. In my example here, I'm using a function that will return true if the item is an even number. And this gives me a way to select all of the even numbers from my original array containing the numbers 1 through to 5. If we have a look at the output, we see that it has correctly selected the even numbers. A similar function is the all function. All returns true if the function given to all returns true for each item in the source array. So this time I'm using a function that will return true if the type of the item is number. And I'm calling it on an array containing 2 numbers and a string. If we have a look, we see that the output is false because not every item in the array is a number. If I remove the last item, the string, and try again, now the output is true. Include is a simple test to see if a collection contains a certain item. I have a list of ingredients: wheat flour, sugar, salt, peanut and caramel, and I'm going to ask that collection if it includes peanut, which of course it does. When we have a look at the output, we see true. Finally, max is a function that returns the largest value for a collection. This time around I'm using an object as my collection. Most of these functions will work with arrays or objects. Because I'm using an object, max will return the highest value of the properties in my object, which is of course 3.